Now, in order to continue the problem, we would of course use the same information, as it is still a 25% by mass sugar in water aqueous solution. And in the third part of the problem here, we're asked what mass of water is there in a sample of solution that contains 3.75 grams of sugar. Well, first, a new piece of information has been introduced, so I write it down with number, units, and label. And then my second thought is what quantity is being requested, and this time the quantity being asked is mass, and specifically mass of water. So I'd like to start with the quantity. Very hard to get lost if I start with what I'm looking for. So I go looking through the data. This is a mass, but it's a mass of sugar. This is a mass of water, and it's combined with a mass of sugar, so I'd have to cancel a mass of sugar. And here is also a mass of water, but if I use this to start the problem with a mass of water, I'm going to have to cancel a mass of solution. So it looks to me like this would be the logical choice for mass of water, because if I start with this mass of water, I'll have to cancel a mass of sugar, and as I was given a mass of sugar, I can do that in one step. So I'm going to start with this ratio. However, I am going to invert it, which is perfectly legal. After all, if there are 25 pounds, grams, or kilograms of sugar for every 75 pounds, grams, or kilograms of water, that means there are also 75 grams, kilograms, pounds of water for every 25 grams, kilograms, pounds of sugar. So I'm simply going to start with the answer, 75.0, and I'm going to use grams as my mass units of water per 25.0 grams of sugar. Essentially, I am starting with the answer yet again. Of course, there's a quantity I don't want, mass of sugar. But since the problem gives me the mass of sugar, I can easily cancel with that mass of sugar. Boom, boom. The rest is grabbing my calculator. And with 3, 3, 3, all three are measured quantities, I want 3 significant digits. And since my calculator reads 11.25, I'm going to write 11.2, because when I have 2 followed by exactly 5, I always like to round to the even digit, and this would be grams of water. And the problem is once again complete. I have a mass of water. Well, in the fourth part of the problem, and I'll do a quick erasure before we do that. Let me get rid of this information here. It's not wanting to erase quite well. There we go. I'm going to introduce another quantity once I select my pen. So in the last part of the problem here, I have a new piece of information. This 3.75 grams of sugar no longer applies. However, since it's the same aqueous solution, all of these ratios still apply. But in the fourth part of the problem, I'm given another ratio. It tells me that sugar, I guess that would be the whole, is 40%, and this must be the part, carbon by mass. So I'm not going to write a percentage, just as I didn't write this percentage as a percentage, I wrote it as a ratio. I'll write this one as a ratio as well. Namely, there are 40 to 100 part to whole. These have to be mass units of some kind because it's a percent by mass. And then I have to label correctly the part and the whole. And if you're wondering what's the part and what's the whole, and some people do confuse the sugar and the carbon, which is part, which is whole, replace the number with the word part, and you know what's what. It's saying sugar is part carbon. So the sugar must be the whole, and the carbon must be the part. So I'm being told, if I'm being told that sugar is 40% by mass carbon, there are 40 parts by mass of carbon for every 100 parts or whole parts of sugar. Now, I'm not sure what the other parts of sugar are. Is there more than one? Is there some other element? So I can't really write the other part to whole ratio in this case. Here, I could write the other part to whole ratio because I'm told what the two parts are. I'm told that we have sugar and we have water. So I knew the other part to whole ratio and the part to other part ratio. Here, without knowing what else is in sugar, I can only write the part to whole ratio. So in case you're wondering why I haven't written down all three, that's the reason. But I do see another piece of information that needs numbers, units, and label. And that piece of information is 3.77 milligrams of carbon. Well, now that I have everything with numbers, units, and label, I follow the same procedure. I ask myself what quantity is being requested. And in this case, the question says what mass of solution, blah, blah, blah. And the blah, blah, blah doesn't really matter to me, because if I start with the right answer, I'm going to end with the right answer. So I go looking for a mass of solution. Well, this is a mass of sugar, not a mass of solution. That's a mass of carbon. This is also a mass of carbon. Mass of water, mass of sugar. Well, here's a mass of solution right here, but here also is a mass of solution. So I'm going to be starting with one of these two ratios. But one is always a better choice than the other. So what I need to do is sort of plan ahead here by thinking, okay, what if I make this my mass of solution? Well, if I do, I'm going to have to cancel a mass of water. And if I look at all this data I've been given down here, none of it includes water. On the other hand, if I were to select this mass of solution to begin the problem, I notice that I'd have to cancel a mass of sugar. And I go, aha, I've been told information about the mass of sugar. I'm going to give this one a try and see what happens. I'm going to start the problem by saying there are 100, and I look for good mass units to insert now. And since the mass units given to me in this part of the problem are milligrams, I'm going to call them milligrams of solution for every 25 milligrams of sugar. And there essentially is my answer. But I have to cancel a mass of sugar. There's a mass of sugar, but if I use it, I'm going to have to then cancel a mass of water. Here's a mass of carbon, so that's not sugar. So here is a mass of sugar, and if I were to use this, I would have to cancel a mass of carbon afterward, but that's not going to be a problem because I see a mass of carbon right there. So I'm going to cancel the unwanted mass of sugar with this mass of sugar. I'll rewrite the ratio inverted, namely there are 100 milligrams of sugar for every 40 milligrams of carbon in the sugar. I have now canceled the quantity mass of sugar. True, I have substituted a new quantity mass of carbon, and that still isn't part of my answer. I don't want that mass of carbon, so I need to cancel it. But of course I can cancel it because I've been given a mass of carbon in the problem. I've been given 3.77 milligrams of carbon, and the mass of carbon cancels the mass of carbon, leaving me with a mass of solution, which is what was requested. I grab my calculator and I take 100 and divide by 25, multiply by 100, divide by 40, multiply by 3.77, and I notice that I have a 3-digit measured number, a 3-digit measured number, and a 3-digit measured number. So I want to write down my 3-digit answer, and that answer is 37.7 milligrams of solution, the correct answer. So once again, by writing percentages, albeit now erased percentages, But by writing all percentages as part-to-whole ratios and part-to-whole ratios for all percentages, and by taking every piece of data, including things that aren't ratios, and writing them all with numbers, units, label, number, units, label, numbers, units, label, number, units, label, it's very easy to solve most chemistry problems. Just start with the answer. What am I looking for? A mass of solution? Not a problem, because if I have put labels and units, I can identify the masses, and then I can identify what they are masses of. And so if I go looking for a mass of solution, I'll see a mass of solution, and I'll start right away with my answer. And if you start with the answer, you're going to get the answer. It's like doing a maze. The quickest way through is to start at the finish and go to the start of the maze, because it's designed for you to meet dead ends if you start at the beginning and try to reach the finish. This eliminates the dead ends by starting with the answer and canceling quantities you don't want. You end up with the very answer you started with. So in the next part, we're going to take a different problem and incorporate everything we've learned so far about factor label problem solving. We're going to go ahead and do some factor label problem solving with both percentages and densities.